I have a question that I'd like all of you to answer, and this is for the non-epidemiologist. It seems like 1.00 seems to be the holy grail that everybody talks about, and I think you called it unity. So how does a non-epidemiologist interpret these data? Because I saw one or two of the presentations where it was up to 2.4, and yet there was smoking. There's also the confidence interval issue. So how does one who doesn't have expertise in those areas look at these papers and draw any reasonable conclusions?
I'll try to answer that. The first question that I didn't get a chance to answer earlier, and I think you posed it, was whether limitations in an epidemiological study limit the applicability of those results for regulatory purposes. And I think we have to go back to the basics. Epidemiology is an observational science. So you take data and people as they are presented. It's not experimental where you can choose the animals, choose the duration of exposure, the intensity of exposure, and so forth. To answer your question about how to interpret epidemiological studies, that's a complicated question that demands a rather lengthy answer. In fact, I give a lecture that takes over an hour on how to interpret epidemiological data. Okay, the first thing that you look at, as we did earlier, is the SMR, which is the rate of disease in the study population divided by the rate of disease in whatever reference population you use. The next step is to determine whether the results are statistically significant, which means how likely the results are due to chance. By convention, we use 95% confidence limits. So if the lower limit is greater than 1, that means we have 95% assurance in the data that it's not due to chance. Now, in any study, and all the people here, John and Tom and May could say the same thing, when you write a paper, part of what you include in your discussion section are the advantages of your study and the limitations of the study. Now, in epidemiological studies, the three major limitations are chance, confounding, and bias. Now, by bias, I don't mean someone's perspective about whether they're pro or anti-industry. There's various types of bias that can be introduced in a study. There's selection bias, there might be recall bias in a case control study. So there are a lot of factors that have to be considered. But the fact that any observational study or observational science like epidemiology, by definition, will have limitations. That does not mean the data need to be tossed out. It means the data need to be considered in light of the limitations. I don't know if that helps, but we talked a little bit about dose response. Is there a link between the risk of whatever health outpoint you're assessing in light of the exposure? Dose response is critical. Have you addressed confounding? Confounding is a critical issue when you're addressing lung cancer and you don't have smoking data. So, I mean, obviously there are a lot of other epidemiologists up here. My perspective is more as a physician using applied epidemiology. You have some of the best people around here that might answer your question. So there are some key points that I would look at. You can go into more and more detail depending on the complexity of the study. As I said earlier, in that German carbon black study, we started taking people out, the lung cancer cases, and we did what's called a nested case control, which from your large cohort, you pull out the cases of interest vis-a-vis the lung cancer, and you do more detailed analyses of those cases. John, you may want to have...
We'll hear from all of our panel members very briefly.
Yeah, okay. This implies that there is a lot of uncertainty in the dose responses, for example. But my question is, how come that certain epidemiologists come up with very precise risk assessment data at certain exposures?
Well, it depends on the integrity of your data. How reliable your data? Are your data quantitative? Are they semi-quantitative? Are they qualitative? How reliable is the primary information, like any scientific exercise? I shouldn't be doing all the talking.
Yong, you're nodding in total agreement on that one.
The plausibility of the results from the epidemiology data depends also on the information qualities and the temporal orders, and so there are several criterions for judgment of the causalities, I think.
John Fryzek.
I would just add also the repeatability of your findings. So if other studies are finding the same thing, then you're more certain of your results.
Okay.
Yeah. Well, I would say for the TiO2 data that there isn't uncertainty in the findings. There's no dose-response effects in these studies, so there seems to be no effect. So I wouldn't say there was uncertainty in the TiO2 papers.
Okay, and the broader, yes. David Kirkland.
Thank you. I have a question for Tom, and it's a follow-up to the point that Len Levy made earlier. So the bar charts that you were showing with the different strengths of requirement for evidence, is it possible, I'll try to articulate this very carefully, is it possible that an organization like IARC could be applying lenient requirements of evidence to support a positive outcome, but requiring stringent requirements of evidence to support a negative outcome? And is that acceptable?
Yeah, well, I think that is what is going on, yes. You see, I think some of the, because obviously my little diagram there about how confident you need to be, that is not in the IARC preamble at all. There's no help. The working groups aren't given guidelines as to how much evidence you need to have to say you've got credible evidence. And I really do think it would help a lot. I think what some of the working groups are probably doing is saying, well, you know, just, the last meeting, I've attended a number of meetings, and you, for the epidemiology, and you can sense that people have quite a lot of difficulty deciding, is the evidence inadequate or is it limited? And it's because they're really, you know, they're way at the bottom levels of confidence. And I think the decisions are just too arbitrary. I personally would like to, for them to take up this idea that it's more likely than not. If you say something's more likely than not, then perhaps that is enough to be limited evidence. I would prefer that. Also, if I can also say on this Jeffrey Cabot chap, he was objecting to the classification of coffee as a possible carcinogen. And this wasn't addressed in this Neil Pearce paper. Now, recently, IARC re-looked at coffee and moved it down from a possible carcinogen to inadequate evidence. And some of those people on that Neil Pearce paper must have known about this future evaluation, but they didn't mention it. And so it was an example where for Cabot was saying people should not be being told that coffee is a possible carcinogen. It's not helpful. And that's been the position for 25 years. It's been changed. But I think it's because it got that classification for far too little evidence. So.
Okay. Any more intervention? Yes, we've got a number of questions that were sent in on the cards. We'll deal with those in a moment. Sabine Royer.
As the main factor of exposure is the dust, I'd like to know if the safety equipment, as the aspiration or protective respiration mask, were taken into account in the epidemiology studies.
This is a question for
John, I think, because we all know that in the past there were no specific measures to protect the workers, but it's a different now.
So workers are working under different conditions now?
Yeah, no, so some of the plants were using respirators and things like that, and some weren't, and it depended on the time period that they were working. And we did do a correction factor in our exposure assessment to adjust for that. So I can't remember what the correction factor was, but it's in our paper.
So that has been corrected for that? Okay.
It can also be corrected in your data. I mean, if you have measurable data, whether people are wearing respirators or not, you still have your measured data, correct? And you can also do the analysis if you have external concentrations, what the internal concentration would be within the respirator. So there are ways of controlling for that matter.
Okay. More interventions? Yes. One on a card coming in, freshly written down, so thanks. Let's read it. I'm discovering it as you are. On the basis that all studies with GBS are negative for lung overload or cancer, is it appropriate to classify GBS as a mechanism specific to rats? Question to each of the speakers. For example, we've discussed this a bit before. Let's go over it. John?
So I guess I'm not quite clear what the question is. So should we attribute the GBS exposure to?
Yes, I'll repeat that question that we just got. On the basis that all studies with GBS are negative for lung overload or cancer, is it appropriate to classify GBS as a mechanism specific to rats?
So I guess I don't really know the answer to that. I mean, we studied the exposures in humans, which I think are the most applicable. So in terms of if it's, what the relevance is to the rat, I'm not sure.
Okay. Any volunteers?
Well, I think the data do suggest that under conditions of lung overload, rats do get lung cancer, regardless of the particle. I remember when I first became acquainted with this topic, and Joe Morterly said I could grind up this desk and cause lung cancer in rats. That basically any particle exposure, if it induces lung overload and corresponding inflammation, chronic inflammation will induce lung cancer. So I think that's a fair statement. Certainly particle overload in rats causes rats to get lung cancer, but what the central question is whether it matters to humans.
Okay, and yep.
A short question. Is the healthy worker effect the only positive effect to reduce the risk compared to the control group, or are there other positive effects as well?
Well, a healthy worker effect, in my view, pertains more to cardiovascular disease than cancer, but I'm not sure. Other people may add to that.
It's more pronounced in the cardiovascular diseases because you usually can predict the outcome very well. For example, high blood pressure and so on. For cancer, there is no really good indicator at the beginning of the study, so there's quite not good predictable factors.
Okay.
But to healthy worker survival effect, there is created during the follow-up, then you cannot estimate the direction very correctly. Yeah.
Okay. You're looking at it from a bit of a distance in the back, but no less interested, of course.
Right, I'm right out my comfort zone here, so I might get it wrong. Even the question might be wrong. And I think it's for Tom, and I think it's for Helmut. Right? So Tom, I thought it was a great presentation you did. I really do. When you say about the levels of confidence of what IARC are using to make their decisions, I think what we've got in TiO2 is we need to understand that same question, and I think we need to understand it from the Risk Assessment Committee, because I think they're the people who are doing that analysis for our big question about classification, CLP, ANSYS, etc., I think. And if that is the case, and I've got that right, my question is, do Tom or Helmut or anyone else have some level of understanding of how much confidence RAC have in making that same decision? I understand what you said about IARC. Do we have a feel for how confident we are about their level of confidence in the assessment they're going to do about determining if TiO2 is a 1B, a 2, or some other level of cancer agent?
Yeah, so, I mean, I haven't seen anything from the, these recent developments on TiO2. So, I can't comment, but I think the earlier delegate was mentioning how you know the EU uses different. It's a different system to the IARC system, and so I think the more that's understood as to how these different groups are operating, the better, because I think that could explain a lot of these sort of arguments going on.
That's also one question that was sent in on one of the cards. Should the agency provide more detailed guidelines about levels of evidence, inadequate, limited, sufficient? Your take on that? Should it?
Well, yeah, my paper says I think that would be very helpful, but I mean, it would be, obviously there's quite a number of people here that have been part of IARC panels, so it would be helpful to know from them as to whether they think there's any need for you know, clearer definitions of how to move into the different categories.
Okay.
No, I just would like to respond to the previous question. You know, knowing the work of the Risk Assessment Committee, they will heavily rely on IARC, on the IARC recommendation. But I think it depends on the discussion during the process and during the meetings, how to use additional information like I have been presenting regarding the reliability of the animal studies. It's not a question of epidemiology, I think. You know, that is even IARC didn't say it's a 1A carcinogen. The question is, how reliable are the animal studies? And from my point of view, at least in certain cases, like glyphosate or so, IARC made a wrong decision, misinterpreting or insufficiently interpreting the data. And so it's up to present the right comments and to have that discussed in the Risk Assessment Committee.
Okay. And a point you might do for the people who really want to pursue this topic, you can go onto the IARC website and look for their preamble. The preamble on the IARC website goes through how they want people to critically review the epidemiological and animal literature that might address David Warheit's question.
I have been involved in describing the last preamble, you know, and amending the last preamble. You know, we tried to set some frame, but the major aspect is it's always a case-by-case evaluation. Correct. You know, what the argument with glyphosate, well, I'm involved in the glyphosate business now, in the discussion. And, you know, in this case, they said, well, it is sufficient if we have 2 positive studies. And in this specific case, they disregarded all the other negative ones, you know, and that was a problem. But they insisted, well, we have in our guidelines, or preamble, it says 2 positive studies in 2 species. Whether they are positive or not is another question, but anyway, they relied on these 2. And then they disregarded the other. And that is a problem. You know, it's always the interpretation of the guidelines.
I think it intersects with another question we got on one of the cards that reads, should researchers evaluate their own work? And Professor Sorahan, did I understand you correctly in your presentation? You said scientists shouldn't be reviewing their conflict of interest, you said. Scientists reviewing science.
Well, I think there is a conflict of interest. But then I also think conflicts of interest are unavoidable. I think there's, you see, where I think this chap Kabat got some things a little wrong was he criticised some decisions at IARC. And then he sort of said, and I think it's gone wrong because of so-and-so, because it was a researcher perhaps writing the draft monograph, reviewing their own work. But you know, sometimes people promote their own work at IARC and the rest of the panel says, no, we don't think we're not impressed at all. So people don't just get their own way. So, in a way, it comes into the end as to how many decisions do you think have been well made? I think there are too many decisions at IR. When you look at them in detail, they're perhaps not so good. But I think it's coming from people using a level of evidence that's too low. You know, I don't think it's because they're advancing their own papers, really. I think it's down to how much evidence do you need to move into these different categories.
Okay, we've got 5 minutes left, and I see 5 hands going up. So if I can ask you to ask your question in 20 seconds and 30-second answers.
Sorry, I didn't have a question. You mistook my hand, man.
Oh, okay. Then that's one less. Okay, well.
Yeah, so again to IARC, I think one of the differences is also that IARC only considers published literature, whereas other CREMIA do have to consider GLP studies and internal studies that have been submitted to regulatory authorities. And I was also wondering if the RAC put so much evidence on IARC. Of course, it's one of the pieces of evidence they have to consider, but there's also a guidance on CLP that also addresses lung overload as not necessarily relevant for classification.
Okay, let's take the interventions and then we'll deal with them as a package. Professor Levy?
Thank you. It really follows up on, I think, what Professor Graham has said about how strongly you believe different strands of evidence. Don't be if you like, on one strand you've got a rat model where you poke any particle and it will cause lung tumours. Don't let's go into the pathology of those. It gets tumours, it gets lumps and bumps. Then you have negative human epidemiology, which appears to be, from an outsider, as well done as you can, and it's fairly sound and it gives you negative. And somebody has to make almost a belief system. You weigh these two up together, and if you believe, as I do, the rat is actually not very predictive in this particular case, with particles for human lung cancer risk against the same particles, you make a judgment. So it's a really question of the strength of your personal belief system, and that's what's causing the problem. It's not that rat studies aren't done well, they're done very well. They're not just giving you an answer that you can necessarily interpret in a particular way for humans. And you have to, and other people believe otherwise, and we're stuck with that. So we've dissected the evidence about adverse outcome pathways, and either you accept it or you don't, so you're stuck at that particular point.
Okay.
The key point, though, in mechanism is going to be very difficult. Many of you may recall, I believe it was in the early 90s when there were studies about whether gasoline exposure caused cancer. Now, at least in the US, people pump their own gas. So you can imagine if gasoline fumes were considered a carcinogen. In fact, in the rat studies, again, there was an increased risk of kidney cancer. And ultimately, mechanistic studies were done that indicated that the presence of a certain protein in the cortex of the kidney of the rat, alpha-2 globulin, was an essential feature in the mechanism. So there was demonstration scientifically that the mechanism of kidney cancer in rats could not possibly operate in humans because humans don't have that protein that was essential to the carcinogenic process. I think there's no proverbial smoking gun with the rat and the mechanism of humans, but there's enough information that I think one could make a reasonable inference that the rat model is not appropriate for human risk assessment for inhalation toxicology of particles.
Okay, one more intervention on that point, and then we have a totally different question still in the last couple of minutes.
Yes, thank you. I appreciate what Len said about toxicology.
Je lui ai remis.
Yeah, thank you. And I believe your session summarized very well in saying that epidemiology is an art rather than an exact science. So the knowledge of the Bradford-Hill criteria or the Dole criteria are so important. There is one tool you haven't mentioned, any of you. It's the meta-analysis. And I would like to know your opinion about the meta-analysis of flooded epidemiology. Is that proving something, yes or no? Or should we think about very good meta-analysis on good surveys?
John? Yep.
Yes, so meta-analysis are an important tool of epidemiology to summarize evidence of relationships. But again, the meta-analyses are only as good as the studies that go into the meta-analyses. So you have to evaluate each of the studies that go in order to understand what your meta results give you. But there are techniques to control for biases in meta-analysis as well. So.
Okay, one very last question. Intervention number 13.
We have a legal limit for inert particles, 10 milligrams per cubic meter. So based on your studies and based on the dusty environments that you've seen, do you think this is a sufficient protection, sufficient limit to actually prevent overloading of lungs of the workers or no?
Thank you, Jan Prochaska.
Should we lower the limit or should we keep it?
So I guess I'm not going to comment on the limit. I mean, what I can say is that we studied workers with real world exposures, and we didn't see an effect. And we looked at exposure levels, at different time periods, back in the 60s when there were high exposure levels in the plant, and more recent where there were much lower exposures. And again, none of those showed any relationship with lung cancer.
Depends on what you're trying to prevent. 10 milligrams per cubic meter is probably going to prevent lung overload, but it may not prevent cough and decreases in pulmonary function. In fact, there's a lot of recent literature about what we used to call particles not otherwise classified, nuisance dust. The nomenclature has changed over the years. What I've seen most recently, however, is reasonably good. I think it was John Cherry in the UK that proposed a 4 milligram per cubic meter 8-hour time-weighted average for particles not otherwise classified. So 10, at least in my view, may be higher than you really should have, based on non-malignant effects.
Okay. Professor Sorahan, one final thought at the end of this panel. We heard about belief systems. You pronounced the word religious at one point in your presentation. Before we go to lunch, what brings us all together and what is the one thing we can all agree on?
Well, we've got to carry on having open discussions, full discussions, not saying so-and-so person is not suitable. We've got to have as open discussion as possible.
That's exactly what we're going to do after lunch. Thank you so much. Thanks to our speakers. Thanks to you.